Okay, so good morning to all of you. Hope you are able to get my voice.
Good morning, sir.
Good morning. So we have tried to learn the file locking mechanisms by using both open system call as well as FCNTL system calls there as a part of it. Lockf is there by which we can also lock a region of a file. That also we have seen. And then, like essentially, whenever you are developing concurrent programs using critical sections and all that, there is a likelihood that one may enter into deadlock situations. In the sense that, there might be two processes or two programs, A and B, of which program A might be holding one resource, waiting for another resource, held by the other program. All of you must have learned in operating systems something called hold and wait. For deadlocks to occur, there are certain conditions, right? If you can break any of those conditions, you can avoid the deadlocks or you can prevent the deadlocks, in fact. One can prevent the deadlocks by just simply uh, removing those essential conditions for a deadlock to form. One of them is hold and wait. The other one is sequential this thing, what you call, that's what you are actually doing here by just making a request for the resource in a specific order. If you request for any of those resources in that particular order, if all the programs competing for critical sections follow that, the hold and wait can be removed. That's what you are actually doing. Uh, so in this example, it's quite easy to avoid. Both programs should simply lock the bytes. They require the same order or use a larger region to lock. These are the ways by which one can actually avoid or prevent the deadlocks, strictly speaking. Prevent the deadlocks. All right, so I think now we'll have to move on to the next topic called signals. Signals is our interest now. Interprocess communication, semaphores, sockets, signals might be there even before, probably. Development tools. MySQL, no. Development tools. Debugging. Processes and signals. This is what it is. This is the chapter. Signals. Okay. Signal is an event generated by the Unix and Linux systems in response to some condition, right? So whenever some condition happens, an event is likely to happen, and even whenever an event occurs, we would like to run something called event handler. Event handler. So whenever this signal is upon receipt of this particular signal, a process may in turn take some action. How do you initiate the signals and all that? We use the term raise to indicate the generation of a signal, and the term catch to indicate the receipt of a signal. Signals are raised by some error conditions such as memory segment violation. They can happen like while running a program, whenever certain what it is situations occur by which you cannot recover from that on its own, like memory segment violation. You are trying to access an index in an array on which you don't have any memory that is allocated to you, right? You are going beyond that. You have declared an array with 100 elements, but you are trying to access a thousandth index element at the thousandth index location. You don't have access to that. So in such cases, it's going to terminate the program by giving some debugging information in the form of core file, all that. Floating point processor errors, like whenever you try to divide with zero kind of thing, divide by zero. You don't know what that value is, and you cannot continue running the program beyond that after that, or illegal instructions. So your processor has got certain instruction set, and you are trying to execute an instruction that's not there as a part of it, right? Or you are not authorized to execute that particular thing. So in such cases, the signals are going to be generated. Different signals are there meant for different uh, events or different conditions that are occurring there as a part of it. They are generated by the shell and terminal handlers to cause interrupts and all that. So there are a number of signals, as you can see. These are the names and what it is supposed to do. Signal names. Actually, these are the names, and each name is associated with a constant. In fact, some number is there associated with them in the background. So names are always easy for us to remember. That's why. Sig apart, right? So process is going to be aborted, right? So that's one kind of a signal. Sig alarm, an alarm signal. You actually set an alarm so that at the end of some number of seconds or whatever, the alarm must be raised. And on receiving that particular alarm, you would like to run some code as a part of it or whatever. Right? Similarly, floating point exception, SIG FPE, SIG hang up, right? Hang up signal is there as a part of it, by which whenever you are trying to log out, still you want to continue certain things. That is another certain programs you want to run some programs even when you log out, right? So one can make use of this particular signal handler, in fact, SIG hang up, right? What to do whenever somebody logs out, right? So any kind of programs you want to run, you can do that. SIGIL, illegal instruction. SIGINT, terminal interrupt. So whenever you press Control C, right? You press Control C when a program is running, you want to terminate that in the foreground. So that signal is called as SIGINT. Control C, pressing the Control C is equivalent to you are sending the interrupt signal, so that you are instructing the cell to terminate the currently running foreground program. So this is also a kind of inter-process communication. Actually, signals are also a process, a type of inter-process communication. One process can send a signal to another process, and that process can in turn decide what to do whenever it receives a signal. Right? So like this, there are a number of things which you can uh, take a study. There are like about more than 60 such kind of signals are there. How do you send a signal in the command line, in the shell prompt and all that to any process? You can do that by using a command called kill. Kill is a command, right, by which you can send a signal to any other process. So what is the syntax of this? Kill followed by what is the signal number and then the process ID. Process ID. What is the process to which this signal is to be delivered or set? So kill minus HUP, right? Without that SIG, signal names are there, right? So all those signal names, any of them you can actually specify here. Kill minus HUP means you are sending SIG HUP. hang up signal you are sending to 512, right? So this is a simplified, simple command actually, kill. Whereas there is another useful command called kill all, by which you don't have to know what is the process ID, like to which the signal is to be sent. You can even send by specifying the command name. What is the command that is currently running? Right? Most of them are likely to be running in the background. So you just specify the command name. That itself will take care of finding the process ID and then like sending that signal to that particular thing. So kill all. That means all the processes that are currently running whose command is inetd. To all those processes, this signal hang up is going to be sent. So this is at the command level. But how are you going to do at the programming level or at a system call level? The system call responsible for sending these signals is actually like it's not for sending the signals rather, but whenever so and so signal is received, by a particular process, what action you want to do, right? What is the signal handler? That's what you really mean by signal handler. So that signal handler kind of thing, you can register actually. You can register a signal handler with your operating system that whenever so and so signal comes, call so and so function. And that function is called a signal handler function. And the signature of that is very tricky, in fact. As you can see, this is the signature of the signal system call, by which you can register a signal handler whenever a particular signal is received, what to do and all that. So it is actually like the name of the system call is signal, in fact. And this signal system call returns another signal handler, in fact. It returns a pointer to a function actually. Function pointers. Signal returns the existing signal handler. It returns actually. Because you are now about to change the signal handler for a particular signal, whenever you this thing, it is returning the existing one, so that in case you want to again what it is, register the old signal handler back against the same signal, then you can first store this somewhere. After some time you can again return back to that particular thing. So it is a function whose name is signal, and it is returning a function pointer, and it takes two parameters actually, of which the first parameter is an integer. It is a signal number, in fact. It is a signal number. And the second parameter is the that particular signal handler, which is a function pointer. That's why it is slightly involved, and you can pay attention to that. Once you understand the function pointers, all that, it becomes easy. There are two built-in signal handlers that you can also use, apart from user-defined signal handlers. The built-in signal handlers, they are given the names like sig_ign. Whenever a signal is received, if you want to ignore that, you don't want to do any action on that, then this signal handler can be specified. sig_ign, ignore the signal. Whenever you want some default action to happen for a particular signal, then you can use sig_dfl, default behavior. Let me just take you to the command prompt. There is something called section number 7. And in this section number 7, you have a signal. It's a documentation actually, a man page for signal. So when you give this, it is a Linux programmer's manual, signal overview of signals. Lot of information is available on this. You just simply read this to get some idea about and all that. As you can see, the entries are like term default action is to terminate the process. Anyhow, ignore is like these are the meanings you are actually talking about. The term default action is to terminate the process. Wherever you mention T or M in the following table, we will come across a table actually, a signal table, whereby it's going to give you all the signal numbers, and then what are the default actions? What are the default actions? And whether you can ignore the signal or not. So that kind of lot of attributes are there as a part of signal table, which is going to come. In that, where there is a column where if you mention a term, meaning that default action is to terminate the process. IGN, in case it is mentioned, default action is to ignore the signal. Core means a file by name core is going to be like dump after terminating the process. Stop means default action is to stop the process. Continue means default action is to continue the process. So these words will be there. We'll come across that particular thing. Let us see here. How do you send a signal? These are the methods. You can send a signal by using a system call also is there, by using which either a system call kill or program command kill can be used as a part of it. Raise is used actually to send a signal to its own process. If you want to send a signal to ourselves, to our own process, then you can use raise. Whereas kill is a system call by which you can send a signal to another process, to another process. So this is what actually I am talking about. Just a minute, because it's not fitting into. Right. So now if you, this is the table what is referred at the beginning. So these are the various signals that are possible, of which if you see signal hang up, right? This is a constant name or signal name. The value of that is actually 1. These values may differ actually from system to system sometimes. So you can't take chances on the values, but the constants are always, they have the same meaning. So signal hang up, if you see, what is the default action? What is the default action? Is to terminate the program. So if you don't register or change the signal handler for this particular signal, the default action is to terminate the program. Hang up detected on controlling terminal or death of controlling process. Similarly, sig interrupt, the default action is to terminate the program. Interrupt from keyboard is to terminate it. Signal quit, the default action is to terminate and also ultimately create a file called core. Create a file called core. So core here meaning that the process will be terminated and also a core file will be created. And you can use the debugging tools to examine what happened, like what is the last instruction that was executed, when the program is running. So what is the reason behind this program being terminated? All that you can actually examine by using the debugging tools. Similarly, SIGIL, illegal instruction. So core file will be created. Abort, illegal, like again, core file is created. Floating point exception, core file is created. So then SIGKILL. This is actually what is called as kill signal, right? And default action is to terminate the process. Is to terminate the process. And then there are segment vector, like invalid memory reference and all that. So there are so many other things. You can just pay attention to these things. Of which, like there are certain things that are going to be ignored here. As you can see, IGN means ignore all that. But remember, this is another important thing. The signal SIGKILL and SIGSTOP, SIGKILL and SIGSTOP cannot be caught. What do you mean by that? So you cannot change the signal handlers for these things. Only the default behavior only will be there. So they cannot be caught, blocked, or ignored. So, the control is taken against every process. Because if you by any chance block all the signals so that nobody can do anything, the process will go on, even when any kind of thing is there. So you cannot terminate the process if somebody creates such a process. And the system administrator would like to stop that. So you cannot do anything. So that's why the operating system designers have set aside this particular signal so that whenever the system administrator wants to terminate the process, right, being run by somebody, so you can send this particular signal, SIGKILL. SIGKILL is something that cannot be caught or ignored as a part of that. So you can see the corresponding value is 9 and we call it as SIGKILL and all that. So now we can just take a look into here, for example. So you might say sleep followed by some 30. And then you say ampersand, right? So here now, kill. So now we'll have to actually use -9 or something. Minus, I cannot type it so easily. By the time will be over, but it doesn't matter. So, but process ID is 4086. 4086. You see, so the process 1 is killed. So like this, you are going to get the corresponding message. Right? One can send the signals in this particular manner. -9 is that way, or the other way is hang up. So you can say HUP. But right now, process ID 4086 is not there. No such process as you are actually getting. Whereas again, if you run this, 4161 is what you are actually getting, 4161. So like this. So hang up, 1 plus is hang up, 330. And if you give PS here, none of them will be there as a part of that. The other way is we can run the same sleep and then kill all, right? Kill all. And then again, you have to use minus here. Kill all. And then -9 followed by sleep. See, like this, process name can be specified. That way also you can terminate that particular thing. So if you by any chance run more than one process, like sleep 30 in the background, another sleep maybe 40, another sleep let us say 60 kind of thing. So one in the background, the another one in the background, this one also in the background. So three programs, 4191, 4192, 4193. Three programs are running now. So if you want to terminate all of them, this is the easiest way. All programs whose name is sleep, you want to terminate, you can see all of them are killed at once. Whereas if you want to individually kill a particular process, you have to specify the process ID, 4191 or 4192. So that kind of stuff. Anyhow, so this is how you can actually communicate the signals and all that. This is in terms of the what you call command level interface. So you also have like man followed by 2 and then kill if you see, probably, right? So this is how it is. Send a signal to a process and at the program level. So what is the signature of this? Kill returns an integer. So whenever it is failed for some reason, it returns -1 as usual. Otherwise, it returns a system call can be used to send any signal to any process group or process. So first you have to specify the process ID and then the signal number. Right? So process ID and then the signal number. If process ID is positive, then the signal SID is sent to the process with the ID specified by PID. If PID equals 0, then signal is sent to every process in the process group of the calling process. See? So if you want to send to all the processes within the process group, so then you can actually send like to all of them at once by using process ID equal to 0. If PID equals -1, then signal is sent to every process for which the calling process has permission to send signals except for process 1. That means if you want to send signal to all the processes that are running in the computer system, then you just simply say PID equals -1. So you make PID equals -1, then it's going to send signal to each one of them, except only one process will remain at the end of it. It's a very dangerous entity. If PID is less than -1, then signal is sent to every process in the process group whose ID is minus process ID. So like this, it has got a lot of features by which we can always do that. If signal is 0, then no signal is sent, but existence and permission checks are still performed. So whether do you have, is it possible for your process to send signals or not? On success, you can see 0 is returned. On error, -1 is returned. And what is the reason behind and all that? So that is the kill system call. But mostly like how do you register the signal handler, right? How do you change the signal handler? Is there in the second group only, right? So this is the one. MCC signal handler. What is the signature of this? This is an easier way of defining the signature for signal. So type def void star sig handler underscore t of int, right? Of int. What is the meaning of it? You are actually defining a function pointer here by name sig handler underscore t. Sig handler underscore t is a function pointer. So what kind of function that it is pointing to? It is pointing to that function whose signature is that it takes one integer as a parameter and returns void as a value. It is a function pointer that takes a single parameter, single integer parameter and returns void as the return value. So that is a sig handler underscore t is a what you call type definition. And this is nothing but your what you call signal handler prototype. Now, using this particular definition, it becomes easy. As you can see, you can understand this signature easily. Sig handler underscore t is a function pointer. It is a function pointer. And what is the name of the system called here? Signal. So it is returning a handler. It is returning the old handler, in fact, old signal handler. What are the parameters for this? First parameter is the signal number. Second parameter is the new handler. What is the handling? What is the action to be performed whenever this number is received? Whenever this signal is received, what action is to be done? And the old action is returned by the signal anyhow. So varies from Unix to Unix and all that. There are several other things there as a part of it. Just now we said there are two predefined functions that are there, function pointers or signal handlers, one by name sig underscore IGN and the another by name sig underscore DFL. Sets the disposition of the signal to handler, which is either this or this, as a part of it. Signal sig kill and sig stop cannot be caught or ignored. Right? This is very, very important. Signal returns the previous value of the signal handler or sig underscore ERR whenever there is an error. Sig underscore ERR on error. So that's what you'll have to indicate. Now let us actually study the programming part of it, and after that, how are you going to write the programs? How do you change the signal handler so that user-defined function is going to be called for that particular thing? That's what is being talked about here. The function ouch, OUCH, reacts to the signal that is passed with the parameter sig. So you can see here, these are the header files to be included. And what is the signal handler now? Like this is the function. What is the signature of the function? Like a default signature is that it can be any name, any function in fact, except that that function should take an integer as a parameter and return nothing or return void. So you are defining now void some function name ouch of int followed by SID. So whenever any signal is received by any program, immediately it will identify what is the signal and call appropriate signal handler by sending the signal number also to that. It is also sending the signal number. So that it is possible for you in fact to register the same signal handler for multiple signals. Either when SIGINT comes or SIG hangup comes, you want to do the same action, let us say. Then it is going to be there. In such a case, we know that this function is called either because of SIGINT or SIG abort or SIG hangup. Then if you want to know what is the signal, what is the reason why we are here, then you can use this parameter in fact. That's the reason why this parameter is there. So you can see here printf out, I got so and so signal SID, and after like taking the action, if you want, you can change the signal handler after doing that. So that's why you are again invoking signal off. How do you invoke the signal system call? Signal off, you call and then specify what is the signal number. In this case, interrupt SIGINT for control C. Control C is equivalent to SIGINT. And what is the action now? New handler is SIG underscore DFL. So you are again putting the like a default action back onto your interrupt signal handler. So only one time only your own user-defined function will work. After that, it is again changing back to the default action. Default action is to terminate the program whenever SIGINT comes. So this is a user-defined function, but then what is your main function? Main function is also int main. And here in the main function, what are you doing? The very first thing is you are registering the signal handler for the SIGINT. So signal of SIGINT comma OUCH. See, you are not calling the OUCH function, remember. You are not calling the OUCH function, but you are registering. That means you have to specify only OUCH as OUCH only. No parentheses and then doing all that. These are advanced topics where you are handling the function pointers, right? So very, very important. So OUCH is the handler that you are registering against the signal. Now what are you doing? You are entering into a kind of a loop, forever loop. So in case you want to terminate this, you press Control C. Whenever you press Control C, now what will happen? It will call the OUCH function. So it will come here. So calling this OUCH function is happening in a asynchronous manner. So you don't know when it is likely to happen. That's what you really mean by asynchronous mean. So after this, as you can see here, Control C 1. This is the name of the function, name of the program that you have put. It is printing hello world, hello world. At some point of time, you press Control C. Immediately, as you can see, you get this particular output. Oh, I got a signal number 2. Number 2 here stands for reverse SIG-INT. If you press once again another Control C after some time, because in this thing, the signal, again you are changing the signal handler back to the default action. Default action is to terminate the program. That's why only one time only you are going to get this user-defined behavior. And after that, if you press, after some time, if you press once again a Control C, you will get the dollar plot back once again. Right? So it is a very simple program which you will have to understand. This is what it is. In order to change the signal handler for any particular thing, you can choose anything for that matter. Hope you are following like what's going on here. Your own interrupt routine you are writing and then doing the corresponding thing. Let's take some other programs. How do you send the signal? This is how it is. Just now we have already seen signature of the kill. Sending the signals happen like this. Kill or process ID and then the signal number. There is another system call called alarm system call. How do you generate a SIG alarm signal? So one can generate a SIG alarm signal only by first calling the alarm system call. Alarm of how many seconds? At the end of this many seconds, SIG alarm is raised. SIG alarm signal is raised actually. This is what you can see. SIG ALRM signal is sent to its own process. So that if you want to take some action at the end of some every fixed number of seconds, if you want to repeat something doing at the end of every 10 seconds or 5 seconds, then this alarm system call will be helpful. Alarm of so and so, so many seconds. Now we can take a look into a simple program. So I have all the header files. And then you are saying static int alarm file equal to 0, whether alarm is raised or not, that kind of a thing. So this is a signal handler now. Thing is the signal handler. The name can be anything. Remember, what is the when can you call something as a signal handler? It can be any name, as long as it takes an integer as a parameter and returns a void. So any such function can act as a signal handler function. Earlier we have written OUCH, ouch. Now he is writing a signal handler as a ding, DING or so and so. The action part can be anything inside that logic. Earlier, you have only because you are trying to learn something, you are printing the message saying that, yeah, I have received so and so signal. And again, you have changed the behavior of that. If you don't change the behavior, the old thing will still continue for any number of times. So here, so whenever ding is there, like whenever signal handler is called, alarm fired is set to 1, right? You are setting the constant, like this particular variable value with, initially it was 0. Whenever a signal is received, it becomes 1. Now you can see here, so what are you doing? So you are declaring one process ID variable, alarm application. You are creating a process, right? PID equal to 4. That means you are creating a child process. And then switch PID, this you already understand. -1 means there is an error, you are taking care of this. So 0 means it is a child process. In the child process, what are you doing? You are actually sleeping for 5 seconds. You are sleeping for 5 seconds. And then you are sending the signal by using the kill system call. Child is sending the signal. To whom it is sending? It is sending the signal to the parent. So as you can see, kill of get PPID. Get PPID returns the parent process ID. So kill is like this, the child is sending the SIG alarm signal to the parent. So one way is you can use the alarm itself, right? So because it is a kind of inter-process communication. So child process is sending SIG alarm signal to the parent process and then exiting anyhow. So what is the parent has to do? Parent must have registered somewhere. You have to register that, right? So you can see case 0 is so and so is over. And then the parent process arranges to catch SIG alarm with a called signal and then waits for the inevitable. So what is going to happen? So somewhere here, I think case 0 is there, and switch off PID 485, case -1, P error 4 failed is okay, exit 1 is okay. Case 0 is all that particular thing, and then you are doing that. So what is happening is like you are having this switch statement, only addressing what? Addressing the error situation and addressing the child situation. So child anyhow is exiting here, as you can see. At the end of that, after sending the signal alarm, child is exiting by using exit of 0. But then like in the parent also will call this particular thing switch off PID. So it's not an error as such. It's not even this. So none of them will be there. Parent will continue the next line. Parent will continue the following line. So that's why this printf statement is going to be executed by the parent process. Anyhow, even the error one also is likely to do that. Error is there, error is exiting anyhow. So error also will not come. Because whenever it is an error, it displays error message and it is exiting, it is terminating. Whenever it is a child process, it is waiting for certain 5 seconds, sending the signal and terminating. If it is none of them, that means it's a parent process. Parent process, so it is doing something here. As you can see, printf waiting for alarm to go off. So what is to be done? So you just simply say signal off. So whenever so and so signal comes, you call so and so function. You call the ding function. So you have registered. After that, it will continue. So here, as you can see, there is another system call called pause system call. Pause system call will make the program to wait actually. To wait until a signal comes. It's going to wait forever, in fact, forever until a signal comes. So when is the signal is likely to come? Signal is likely to come from the child process. It can come from anywhere for that matter. It is going to come from the child process after 5 seconds being elapsed. So that's why the moment this kill is executed by the child, that signal is received by this parent process and which is waiting in the pause this thing. The moment this is over, like it will come out of it in fact. The moment like what it is, signal comes, pause will get out of that. So because of the signal handler, already alarm fired is already set to 1 now. Earlier it was 0, and in the ding it is set to 1. So you are now call what it is verified. If alarm fired, printf ding. You see, this parent process might receive the signal other than alarm also. It might receive alarm or it might receive something else. Whenever it receives any signal for that matter, it will get out of this. If by any chance it has got out of this because of the signal alarm, then alarm fired must have been set to 1. If it is because of something else, because of some other signal is being received, then this will still be 0 only. Right? Printf done and all that. So you can see here now how it is going to be tested. So you are running this alarm application starting, waiting for alarm to go off, 5 seconds pass, and then ding. This is the output. This particular thing is the output here, ding, and then done. Right? So this is there. But how do you actually get a situation where you don't get ding at all? You have to send some kind of interrupt signal or something to that. Then you will see. Then you can see that ding won't come, but something else will come. So here pause is being explained. Pause is, as you can see, the program introduces a new function called pause, which simply causes the program to suspend execution until a signal occurs. Signal might be any signal. When it receives a signal, any established handler is run and the execution continues as normal. That is the purpose of the pause. It's equivalent to you are waiting for a signal to arrive. That's what you really mean by. And then alarm clock and all that. Now you can just take a look into the following one. These things you don't have in fact, sig action, these things you don't have as a part of the syllabus. Only signal is there, kill, alarm, all those things are there as a part of it. This is not there, not required. But the sense, this is another way of working on the signals. In fact, it is a latest trend. In fact, but you don't have this. You don't have to actually learn this particular thing. Up to this only, you have to complete. Let us see. Is there anything beyond this? These things are not there. Signal sets and all that. Suspend, flags. In the signal handler, normally it is a good practice not to do a lot of things because some kind of suspend, it's better to call some of the functions that can work without any data inconsistencies and all that. So a list of functions or system calls that you can call within the handler, within the signal handler, that are really safe there is giving a kind of a complete list as a part of it. And these are the signals there, summary. So that's all I think, right? So as far as signals is concerned, this is all that you actually require. If we want, we can actually test it so that some kind of mechanism we can do that. Let me just copy this particular program and then do something for you. Right, this part of it. I will show you. Okay, so up to this, you'll have to copy it. Let me copy this. And now go into this mode. So here you can use the editor here. Then use the paste. So naturally all this. This is save it, save as. Within this network programming, somewhere we have to select this thing. Okay. And then the name of this can be anything like signal handlers, like essentially, this is about whatever. Uh, we'll just simply call signal demo kind of thing. Sig hyphen is required this hyphen demo dot c dot save it. Okay, so now so a lot of unwanted things are there. We'll have to okay signal. So enter also is there as a part of it. So like this. So at include followed by these things are to be there. Int main. Sorry. Case -1. Then these things you don't require. That's only a comment. Uh, uh, right. So this is the switch statement. So comment can be there or it can be ignored also, no problem. Oh, we have to close this. This we have not copied. All right. So save it. So this is the program corresponding to that. So signal handler is there, and then you are invoking the process, creating a process, and then these things. Only whenever it is an error, it displays the error message, and then terminates. If it is the child process, waits for this, sends the signal, and then terminates, and then terminates. So whereas if it is none of them, that means in the parent process, none of these things happen, so it will come out of it. The parent process will continue into lines 27, 28, and all that. So parent process will actually display this message and then register the signal handler and then wait for that particular. If alarm fired is made to 1, then you get ding. Otherwise, because of something else, you will get all that. So now let us actually go into this particular thing here. So where are we? We are in this particular. Now you have to compile it actually. So because for me the letter C is not working properly, I made S is equivalent to C kind of thing to some extent. GSS followed by what? Followed by our signal and all that, signal demo, and then minus O, minus is required now, minus O, and then like this. Printf O. So some individual characters are there while copying from PDF files. So these problems are there actually. So after printf done, there is some individual characters. So line number 33, there is a problem. Any other thing? So this kind of issues are there. Copy paste. Uh, all the problem is there in 32 and 33. 32 and even 28. There also you have 28, 32, 33. 4 failed. So wherever that kind of thing is there, you are getting that. P error from incompatible pointer type. Oh, uh, oh, okay. Let us see. Printf alarm and all that. Okay. See demo. 14th line. Alarm application starting. 14th line, there is a problem. Essentially, the double code business. Actually, the double code is not properly copied. So let us come back to this. Right. So here, if you see, it is something else actually. So I'm just removing that and again typing that. So that is a slightly, it has understood in a slightly different way. So in all those places we can do that. Probably we can replace that. So what we will do is uh, copy paste. We are going to do that. Copy. Now find and replace. Use the find and replace. So search for this special character and replace with normal double quote. That's what you have to do. Replace it. Find a close dialog, in document and all that. Find, replace, replace. Use regular expression. Right. Section replace all must be there. Replace all. Replace and find. Replace. Okay, so that's done there. No problem. So this kind of error is now rectified, but only one thing only it has done. I think that problem is there. Okay. It's not there. Somehow that character may be something different. Still, this is actually doesn't appear to be the same. Maybe that is a different character. So sometimes when things are small, less in number, we can do like this also. Oh, this is also not changed. Okay, so let us now compile it so that number of errors might be reduced now. So now you compile it. Oh, so all the errors are rectified. Okay. So these things will be there. Like why I'm doing all this is like because whenever you do that, you also will face the same problem. So I'm just giving some solutions here as a part of it. So copy paste. So that kind of errors are likely to come. So rectify them. And now you have to run them. If you just simply keep waiting there, like not doing anything, so alarm application, ding, and that. So like this you are going to get. But if you actually, okay, let us send a different signal to that. How to actually do that? So if you press Control C, what happens is it will terminate altogether. That problem is there. Like how to see that you don't get ding there. That means you have to, that part should get out of that because of receiving a signal other than alarm one, other than the alarm kind of thing. So there are different ways it can be done. In fact, one way is by changing the program itself. Like what it is, as you can see here, don't send the sick alarm signal here, but instead you send something else, right? uh, what it is, instead of SIG alarm, you send SIG INT, SIG INT. And you compile it again. Now what happens when you run it? When you run this particular program, so the parent process doesn't get the alarm signal now. It's going to receive the interrupt signal. For interrupt, there is the default of this thing. So what is going to happen, as you can see, right? It's not displaying anything because it's terminating. The parent process is receiving the interrupt one actually, SIG interrupt. That's why it is terminating altogether, right? So whereas what you can do is probably you have to have some other some different action altogether. For example, what is to be done? I want like this done to be displayed, but the ding should not be displayed. So such a scenario, how do you ensure that? How do you ensure that particular thing? So what we can do is we can register another one, another function. In fact, we can register another function here, which is going to do nothing kind of thing. We copy the same. Sorry. Instead of ding, you call it as do nothing or some kind of thing. Nothing, right? Do nothing. Nothing of this. That means no action part. Is it possible like this? Let us see. And here you register. You register for that one also. So what it is, whenever an interrupt comes, whenever an interrupt comes, what is the action? Do nothing. Nothing. Is that's the name that we given, right? Nothing is the name, right? So and then all that pause, alarm fight, right? So what is going to happen? Get PID signal interrupt. So now the child process, instead of sending the alarm signal, it is sending the interrupt signal. So because of which what happens? So whenever alarm comes, it initializes that variable with 1. But if say interrupt comes, it does nothing and comes back. But pause is waiting. It will get out of pause either when any signal comes, right? Any signal comes. Now you can actually compile it. Now you see, run this. You see now, you are getting the done this thing. It has get out of that pause system call because a signal has come. But now it's not the alarm signal, but it is the interrupt signal. So because of the interrupt signal, it has not changed the value of that. value of the alarm file, right? So like this, you can actually write small programs to understand what is going on there and all that. So essentially, it is a very simple mechanism by which one can send the signals by using the kill system call. One can register signal handlers by using the signal system call, right? And then continue there and all that. Pause is there in order to wait for any signal to come. And in fact, alarm also one can actually use. Alarm also one can actually use. For example, at the end of every what you call once maybe 2 seconds, you want to display high, high, high like that, right? So it's not deep there. Let us actually write that alarm business, save as, save as, and then SIG uh, alarm, sig alarm dot save it. Now let us actually look into how we can do that. Alarm, it's not alarm fired and all that. What we will do is we'll display some high or something like that. Printf, let us say hi, a new line. After that, you set it again, alarm off. Let us say some 2 seconds. Alarm of 2 seconds. So what it will do, it will display the odd once every 2 seconds. That's the idea. See, we are removing all of them. Signal off, alarm off, ding. So that is going to be there. A kind of a forever loop we will have it now. Do nothing loop. Signal off, that is done. Now you have a forever loop. While one, the semicolon, let us say. While one, semicolon, do nothing. So it's waiting there. And naturally, alarm 2, alarm is to be executed once at least. Alarm off. Here also you specify 2. So that at least one. Signal of alarm, whenever alarm is come, you call the ding. So you are calling alarm of 2. So at the end of 2 seconds, sig alarm will be raised. Right? So it will go there and print high. And again, once again, you are doing. Only one time only alarm will set. So that's why you go there and again you are resetting. So same signal handler is there. It will continue to do forever. So as you can see, you are not explicitly printing anything, but that's going to happen because of the signal handlers. Let us now run this particular thing. What happens? Like this. So it's okay now. Now you can say like this. See, so at the end of every 2 seconds, sig alarm is raised and the same default action is happening regularly there as a part of it. Now how to terminate this? Naturally, we press the Control C, whatever, like this. So in fact, if you want, you can also see like Control C can be ignored, for example. You don't want like Control C to work properly. How do you actually do that? So even when the user presses Control C, it should not terminate. It should not terminate. How do you do that? by using signal. Sig of interrupt, right? INT. Control C is sig INT actually. So what is to be done? Ignore it. Ignore the corresponding thing. So you say SI G underscore doesn't work here. Underscore IGN. Like this. Signal of SIGINT comma SIG idea. Ignore. Whenever alarm comes, you are calling the ding kind of thing. Like this, you can actually do that. So, for example, now this is the corresponding code, and you save it. You come back, and now earlier we have run that. You are able to terminate that. But now we will again recompile, and you again rerun. So 2 seconds, high, another high, goes on. Now I press Control C, as you can see, Control C. See, even then it is continuing. You are not able to see. So if people write like this, then how do you terminate the programs? Right? Some normal users, if they do that, system administrator want to take the control of this. That's why there are certain signals that you cannot ignore. And one such thing is we have seen SIG followed by HUP. SIG INT is there, and number 9, what we have seen just now. So, like, how do you send such a thing using the keyboard and all that? There are different ways by using Control Shift actually, and then reverse slash. Control Shift reverse slash will send that particular special signal. Do we have reverse slash? We have. See that? This is called a SIG quit. So it's going to terminate. This signal cannot be ignored. So you are able to terminate that particular process. Like this, you can work on the signals there, write small programs. There is hardly anything as far as your syllabus is concerned. So you should have control over signal handlers, sending the signals by using kill, alarm is there, pause in order to wait for the signals. So these are the topics that you should try to acquire the knowledge. Okay, so I think with this we can say that the first mid part is over. From next week onwards, we will study, or rather next class onwards, the socket programming. Socket programming as a part of the inter-process communication, IPC. Okay, so in this, if you have any questions, you can ask. Otherwise, we can close the session for today's this thing. Any questions at this point of time? Okay, so use that particular textbook, use these examples, and then write some sample programs to get control over that. I will now stop the recording kind of thing. Stop presenting. And then stop recording.